Welcome back to the stream, folks. We've just got a bit more of pretty much the same as the last one. Some more CAD, working on the parts for this cat-following robot. Which cat, you might ask? Well, of course, the star of the show, Tuco the cat. Back to the desk. So, desk is covered in 3D printed parts. I moved this camera farther down on the pole than it usually is. Let's put it back up. Hey Tuco, welcome back to this part of the shop. Hi. Welcome back to the stream, folks. So we're back to our CAD and desk covered in 3D printed parts. Basically the 2017 3D printed robot builders workshop, effectively. Got a few revisions of this part we were working on last time. This is the print from the part we actually designed on the last stream. Turns out I was really way too optimistic about how flexible this stuff can ever be with walls this thick. So this is PLA, and I just did not leave nearly enough room to actually insert the idler into this assembly. So then I decided on a different version where instead of being enclosed on the top, I tried making an open top version to see if it would be strong enough. So it turns out actually this one was pretty easy to get the idler into. Turns out the way this one works, this kind of bump at the left side holds the end of the bolt right up until you end up hitting the edge of the bearing. So that's what actually kind of provides a cantilevered support for the bolt itself. And then on the right, that hole fits snugly around the head of the bolt, so it actually provides some support on the other side. But this one was just not quite thick enough, so this would tend to flex out, and then the bolt head would lose its support. And it still worked. It would probably still be strong enough, but it wasn't making me happy. So then this was a slight variation on the design, where I ended up fixing some other things that bothered me, but mostly I was just improving the thickness of that support over there. And you can just barely get the idler in now. It's a tight fit. But once you get the idler in, the bolt fits in really nicely, and then this thing seems nice and sturdy. So that's where the cord comes in on this side, and then it would just exit vertically up at the top. So then this would be supported on the other side, probably mostly on the bottom because the cord runs along here, and then the capstan is probably right around here. So I wanted to demonstrate the process of actually putting one of these together, but we'll have a chance to assemble at least 3 more of these, since there are 4 of these winch robots total. And we're actually printing another one of these right now, so I can demonstrate the assembly process as soon as that print finishes. It's mostly just a little bit of trimming with a knife and then some shoving. I think Tuco's in the mood to play. Hey Tuke, can I take off your collar and give you a bolt? It's already so trippy. Well, he'll be doing that thing. So I've also been thinking about just overall the organization of this thing. Oh, that's a great question from Mike in chat. So Mike says, I guess I missed this part of the design. What's the load cell for? So my idea with load cell was that would be for So, I mean, just what it measures is it measures the tension on the nylon cord coming out of each of these winch robots. So I was planning on using that as a feedback mechanism, but I'm still not entirely sure exactly what that's going to be useful for. I figure at the very least it'll be something that'll help me, have kind of an emergency stop if I start reading something that's way out of range. But I think it might also be useful for more subtle uses, like kind of providing force feedback so that I could maybe move the robot a little bit with my hands and have it notice the change in tension. But I think the thing that I'm most likely to use it for is for trying to keep the tension on all the wires kind of roughly balanced while it's actually up, so that I don't end up with some of the wires going slack and then other wires holding most of the weight. Some of that's going to be subject to the geometry of where it is, but I think given that I have 4 winches and I'm moving it in 3 degrees of freedom, I'll need to make sure that I don't let any of the cords go slack, because I do want to maintain a roughly constant amount of tension on the cords as I'm winding them to keep the winches from getting tangled. Oh yeah, Tuco was wearing his collar just now because he was hanging out outside, but he's been napping on a box recently, so it was kind of just left over from earlier today. So yeah, I don't know how necessary the load cells are going to be. It's more something I wanted to experiment with than something I think is like absolutely necessary for the design. But it seemed useful. So I was also thinking about the power supply. I did a really rough test on the last stream where I just held the spool and kind of loaded it down with my hands a bit to get a sense for, if it's pulling with roughly the amount of force that I want it to at maximum, how much current does it take? And I was getting readings in the power supply of in the ballpark of like 2 amps max. So I figure I actually want this thing to be running without the motors like maxed out most of the time. I want this thing will actually probably be pretty low power, so. I was looking at power supplies in that range, and hey Tuco, where's the bolt? Tuco, I really don't know where it is. So I found some power supplies like these 2.5 amp 24 volt mean wells that actually seem like they'll probably be fine. And if I need something bigger, you can get power supplies in this similar form factor that are a little bit heavier duty at like 3.5 amps or so. But for the motors, this seems like it'd be fine. And then I would use a secondary DC to DC converter for the logic. So what I would likely do is have this coming into a little panel mount DC barrel jack. Then I would just have a bunch of circuit boards in this thing, mostly the eval board with the microcontroller, a little breakout board with the motor controller, and then just a random DC-DC controller floating around, or, not floating, but like attached somewhere, but it'd be small enough that it could go pretty much anywhere. So it may or may not be worth even making a circuit board for this. It might just be something I can just wire point to point because there's only a couple of connections. Oh, there's also a little breakout board for the load cell sensor. So since I'm only making 4 of these, and I didn't really want to have to do a bunch of just like designing everything as a complete circuit board and revving that, I just thought I'd get a bunch of eval boards and just put those together into a box. So the load cells, for example, I found them in a package that came with this eval module. I think that's just I2C over there. I think this is HX711, it says. So yeah, I haven't really looked into this much, but it's like an all-in-one load cell sensor that I plan to use from the micro. So stuff like this. We've got these breakouts for the motor controller. I'm forgetting who pointed this out, but someone was helpful to mention that this 7805 regulator is probably really, really not okay for 24 volts input, which sounds about right. So I can probably pretty easily just pop that off and give this thing some external 5 volts, since I'll have a DC-DC converter. But yeah, I'll have one of these for the motor controller, some random DC-DC converter for the microcontroller, and then the actual micro is the largest thing that I'm dealing with, and that's this board. This is really the reason, the reason I have this is for the RJ45, really. This is a microcontroller with Ethernet, and this whole dev board at DigiKey is like 20 bucks. So it seemed like a pretty inexpensive solution for making a fairly reliable motor controller that I can command over a dedicated Ethernet network. So I'm planning on just using this dev board. We could have a separate panel mount RJ45 jack and run a little pigtail to this one, or I could just mechanically design this so that this is, accessible from the outside, which seems a little easier. But yeah, this was 20 bucks at DigiKey, and it comes with everything you need. It has another, actually another micro from the same series that they have set up as a built-in on-chip debugger. You can use your own debugger, you just have to take off all of these resistors, which is super annoying. That's what I did. So you can program this pretty easily with OpenOCD and Raspberry Pi, which is what I was doing on the GDB Ethernet project. So yeah, one of the first things I actually want to do today is just make a CAD model of this board. Probably a pretty rough one, but this is now the largest remaining component I have. Let me show you what the state of the model is so far. So I got some power supplies, which should be powerful enough, otherwise I'll use them for a different project. I also found, oh, where is this? Maybe I'll have to look it up on Jameco again. So this takes a 2.1 millimeter barrel jack. I wanted something panel mount, and ideally pretty, like a lot, you can find some like ridiculously low-end power jacks, but I wanted something that I would trust with a little bit of current. So this one from Switchcraft looked pretty nice. I got some of these also, and they don't have CAD models, but there was like a drawing that we could actually, this is the one. There's a drawing we could put in CAD. So I don't know how much of this I care to model, but at least maybe knowing how big this thing is and what size hole to make for it will be useful. There's a nut that goes on the front of here that isn't shown. But yeah. Yeah, Jameco's nice. They're local to the Bay Area, so you can get stuff from them relatively fast. I've also found they actually have a pretty good selection of non-sketchy power supplies. So when I'm buying power supplies, I'll often get them from Jameco. Let's see. Oh yeah, and I organized the CAD models a little bit. I finally put this stuff in GitHub. So we do have a GitHub organization for TucoFlyer now. It's just github.com/TucoFlyer. And I didn't mean to magnify that. I wanted to magnify this. Yeah. So we have a bunch of repos in here. I have a couple for the CAD that I've been doing lately. There's kind of a work in progress thing for the actual Flyer software. Right now it's just a little test program that you can control with an Xbox remote. This is the work in progress chatbot, kind of a stub for the firmware. But anyway, these two repos, the Flyer CAD and the Winch Bot CAD, have the stuff that we've been doing in Autodesk Fusion 360 so far. And so I organized this stuff in here to match what we have in GitHub now. And in GitHub, you should see actual exported files for all of this, so it isn't stuck just in Autodesk's cloud server. So in WinchBot, we have bot references and tools. Tools, for example, is our bearing press. References, these are models of kind of outside stuff that we're using, and a lot of it I ended up either finding or making models of. So like, this is the Siny motor that I think Microhex made a model for this for us. There's a bearing I found on GrabCAD. This is a motor that I made that we're not using anymore. This is another one that I made. I guess I made both of these from like eBay drawings. Bot has the stuff that's actually for a robot. And so all of the files that are actually 3D designs from Fusion 360, I saved as both IGES and STEP, which are two different industry standard formats. And then the 3D print files I saved as STLs. And what's nice is GitHub will actually render these in browser now. So you can see all the parts, including all the random little features. So that's the bot itself. There's also a project for the flyer, which doesn't have as much so far. I've also got references in here. These are gimbal related mostly. And then there's a directory for things that are related to the gimbal mod. So I have, again, Fusion 3D, STEP, and IGES files. And then the actual 3D printed pieces are here. There's the cam bracket, the LiDAR bracket, and the rear cover. This is one of my favorite pieces so far. It's like the least useful, but pretty interesting looking. This is just like a wire guide and a cosmetic piece that fits on the back of the camera. But anyway, I'll be saving the new files and saving changes up to GitHub, but still working on it in Fusion 360 for the most part, unless I jump ship for another tool. This is the overall design of the Winch Bot that we have so far. So this is the spool. Hey Tuco, what do you want, little guy? We're making a robot about you. So here's the spool, bearing in the middle, motor. This is the piece that we just made up here that attaches the idler to the load cell. The next kind of load-bearing structural piece kind of needs to connect this side of the load cell, the mounting on this encoder, and the mounting on this idler, and then all of that kind of back to this assembly where we have the spool here, which will be supported on one side by the motor, but then on the other side by a bolt shaft kind of poking through the middle of this bearing. Hey Tuke, what do you want? So I got to this point and I was about to make maybe another bracket that just attached, say, the bottom side of this load cell to the encoder and the next idler. But a lot of that seems like it's potentially just going to become features in whatever the backside support is for this whole thing. So it's looking like this will be kind of the up and down orientation. The cord will come out vertically through here. It'll wind across here, under this capstan, over this idler, and then down around this idler, and then onto the spool, like that. So this idler's purpose is to center it. This idler's purpose is to press the cord against the capstan. Then the capstan measures the cord's progress. It also lines up the cord to be at the right angle to come into this idler so that the force cell effectively ignores the force on that and measures the force on this one. And then this idler is actually where it finally rolls before heading off to the ceiling. So that's kind of where the string's going to go. And my plan for the enclosure is probably that what's on the right side now is just covered by kind of a basic kind of bolt-on piece. And so that'll have basically a bolt embedded in it, like an M6 stud, that ends up holding this. But then elsewhere, wherever there happens to be free space, I'll end up putting long bolts through that half into the back half. And that's what actually ends up both attaching the two and supporting the load on this eventually. And there will probably also be molding features to keep the two aligned relative to each other. Or not molding features, but just like an overlap in the edge. So yeah, I guess where I'm going with this is that the half facing us is likely to be very simple and based on kind of a stripped down version of whatever's underneath it. And then this half, I've rotated the motor up so that this the whole thing can take up less space, just to make the envelope smaller. This whole thing up here is starting to feel relatively compact now. And there's room for some random little circuit boards back here, like, I'll probably want connectors on this side. So maybe a power connector over here. Maybe the microcontroller board is oriented so that the RJ45 is up against this side. But it looks like I'm already a little low in space for that, so maybe it has to be at a weird angle. The motor is pretty big here. So anyway, that's why I think having CAD models of the other parts, especially the electronics, would be really useful at this point. So, Winch Bot, references. Let's make a new reference. Hey, Duke. Oh, there's a bolt. He's so into that. I know, Duco. Okay, let's model this TI board first. He just drops the bolt places where I don't know where I don't have any idea where he puts them. Well. Oh, Tuco. All right, 56 millimeters by 125. And we center this easily. Maybe not. All right, now to the origin. And so there's not a whole lot that I care about on this. You know, before I get too far into this, I think I might actually have CAD drawings for this board, so let's see if we can actually import them instead of redrawing them. Yeah, I think you can actually download a layout for this. Eagle format. What do you know? That's right. I know we've seen these before. Oh, we've got Eagle and Gerbers. We have a PDF of the schematic. Do we have a PDF of the board too? This might be what we want. Except Fusion 360 is actually really bad at PDFs. Maybe I'll cheat and use Rhino to clean this up a little bit. Do we have any other formats we could use? Gerbers? Is it worth going from the Gerbers to anything else? Let's see if this board layout PDF is to scale. And I've already had no luck with PDFs in Fusion 360, so I'm going to try doing this in Rhino. man, where did that file go? Oh, I was like inside a compressed folder. Alright, I don't know if these are going to be the right units, but let's check it out. So, we measure this. That's right, distance. That's a weird place for the center of the circle to be. I think this is maybe an approximate circle. Oh, the center of this octagon seems right, though. How much was that? 2.54 millimeters. Okay, I think this is to scale. It's full of junk, but it's to scale. Did they include any useful layers in here? Okay, well, what do we need? We want the outline here. And actually, am I bold enough to run a curve Boolean on this entire thing? I don't think that'll work out too well. But Rhino has this really nice tool called curve Boolean, where you can just basically throw a bunch of paths at it, and then it lets you select which pieces you want to make closed, and it'll just keep those. So I think I want to give it everything that I want to keep. So I'm not going to worry about all the holes, but anything I might want to use mechanically, I should keep. So it looks like this has 3 mounting holes. And then the rest of them are just like test points and stuff. And I'm not going to worry about these. So and then how thick do I want this board to be? It feels kind of nice to use Rhino after being frustrated at Fusion 360 all day. I mean, I admit the programs both have very different strengths. There's just... I tend to find the UI in Fusion really abrasive these days. Okay, let's move this down. I think I actually want the plane here to be the top of the circuit board instead of the bottom. So let's model the RJ45. Hey, Tuke. Looks like 13.2. No, 13.1. Hey, Tuco. I see it. You brought me a bolt. Good job, boy. What else do I want? There's a bunch of stuff on here about the USB connector. kind of the extent. It does stick out past the edge of the board a little bit. I'm going to measure that against the actual USB connector I have. It's like 7.6 millimeters wide. Eight? Okay, cool. And how much thickness should I reserve for that? 2.8 seems like it'll do it. Anything else? There's some buttons here. I don't know if I care that much about the buttons. Although it would be pretty nice if I could make some of the buttons externally accessible, maybe. I don't know what I would use those for. Robert says, this theory's in KiCad has 3D model support. Probably one of them. I mean, when you're doing package design, you really do want a 3D model of the board. Like, that is actually a thing you want. So if you're getting to that point, then that saves you some effort. And like for me here, I don't need everything. I just need the stuff I'm planning on interfacing with. But if I had a more featureful model, then like it would look nice at least. Hey, Tuke, where'd you put it? I heard it. Tuke, where'd it go? Oh, I had an idea about bolts for Tuco. If I had hoses, like these convoluted tubes that I've been using for protecting wires from him, if I sent bolts down the tubing, it would make a rattling noise as it went by, and I think he would know to follow it. But I don't know if it would be going as fast as he wanted it to be once it reaches the end. Maybe you drop it, it rattles through the tubing, and then it goes through an accelerator at the end. Oh, Dale's asking what CAD package is currently on the screen. This is Rhinoceros. This is something that I'm a big fan of. It's also pretty popular for, I think, architects and jewelry designers. It's not parametric in the same way as like SolidWorks or Fusion 360, but so like the mode I'm using it in right now is pretty much freeform. It's basically kind of like Inkscape or something like that, but for 3D. So it has different strengths. It's pretty easy to just kind of do whatever you want, but it doesn't have as much structural representation of what's going on underneath. But then there's a plugin for this program called Grasshopper that lets you kind of construct things programmatically using kind of visual data flow language, and that's something I'm a big fan of. I haven't used it as much recently, but I would do some art projects with that in the past, and it was really fun. So these are the switches. Do I care about switches? How big are the switches? Oh, I must have a model for these somewhere. But I don't care that much about these. We'll just make these 3.7 millimeter boxes. I'm just using the center of the pad as a reference here. Is that one too? No, just this one. There's a bunch of headers. There's an Ethernet transformer. Let's at least make some room for this. Looks like that's kind of what we're doing. Mm-hmm. 6.6 millimeters will do it. We've got all these really tall headers, like these things. Yeah, so it looks like the center, as far as we're concerned in the PDF export, is kind of far from the actual center, but if we use the center calculated from this polygon, it works out pretty well. And then, how big do we actually want to make these? .6. And how big are these connectors? 10 by 2. X spacing. That was the wrong direction. That's better. There's my header. Let's group these together. And let's make some more of these. That's accurate. There's our pointy bits. There's also a debug interface over here, which we might actually want to leave room for. Yeah, there's a debug interface, and there's a debug interface for the debug interface. So this is a little, this is a SWD header, which is the kind of thing that I could attach the Blackmagic probe to. And this would actually program this microcontroller. If I wanted to, I could use this as some kind of weird double layer supervisor system, but it's likely I'm not going to use this much, but I'll maybe leave room for it. I'm just going to make this kind of an abstract box. Make it a little taller than the actual header. 6 millimeters. And then kind of a similar spot for this USB connector. Oh, are these real circles? Maybe these are real circles. Oh, what was that? That wasn't what I expected. So Some of that is real. I think that's what I want. And then we have the connections on the bottom, and then I think we're basically done with this. Oh, let's also save this. This is fine. I don't have to do everything in the same package. I can do this one in Rhino and then export the parts I need to Fusion. One problem I had to figure out how to deal with, so I imported this motor model into Fusion 360, and it seemed to be just like a hollow shell instead of a solid. So I figured out how to fix that, but because I had done a bunch of my design around that hollow shell, not really knowing that that was a problem, I ended up having to redo some dependencies. So the boxes, they're on the bottom. They're about 8.5 millimeters deep. And they're in exactly the same spot as these. They're just stacking. So let's make a little reference box. Oh wait, that was millimeters. Okay, that's a 0.05 inch box. Nope, wrong direction. Let's turn off some of these selection filters. I think that's what we want. Let's clean up some of this stuff that's on the outside where it shouldn't be. And then see how it looks rendered a little bit. All right, let's group some of this together. Right, so these are poly surfaces, which are I mean, not necessarily enclosed, but collections of objects that have surface representations. I'm going to group these together. Yeah, this is everything else. These are the circuit board traces. Let's group those. Let's also maybe move these very slightly, or like extrude them very slightly up so that they're solid objects. Well, actually, that's going to be annoying given that a lot of these, like the traces here, aren't real. The traces are just single lines. Alright, I guess we'll just leave them as lines. They don't have to be solid. Okay, I think we're done with this. Let's export this. Okay, let's see how this looks after importing it. See if the import-export process treated this all right. So Winch Bot references. So I saved that right into the Git repo directory. So Winch Bot CAD references, and then this eval kit board. Right, you can't drag them in until after you get into upload mode. And then you can drag them into just this particular spot. Time for a little tea break on every import. That seems alright so far. We got boxes. These are bodies. Are these solid? These look like they're solid bodies. Kind of want to join these together. I don't know if I care if these are separate or not. Like in Rhino, it seemed like it was useful having them be separate, but now I'm just like, oh geez, there's so many things here. But that's fine. That's what components are for. So I think that's fine. I think we've got this in the cloud. Now let's import it into this list design file here. And that's how big it is. So is it too big to go this direction in the robot? Oh, maybe not. The robot might be just wide enough to fit the board this direction, which is probably a good thing. Can it fit below the motor? Because that would be convenient. That does make the robot taller than it otherwise would be, though. So what if I rotate it? Am I going to have to put it in there at a jaunty angle? That makes it a lot harder to debug than if it was pointing with the board toward me. But not that much, actually. It can't be that close to the spool, though. It would actually have to be more like... It could be more like that. That does make it thicker than I think it would otherwise want to be, but that's probably fine. I mean, I'm going to need some support for the motor back here anyway. I'm also just thinking, well, taking this opportunity to think about how I'm going to actually build the back of this. Like, it could just be one giant 3D printed piece, but there might be better options. And so far, you can see there's a bit of a logic to how this stuff is arranged mounting-wise. So the axes that have to be strong, or the points that I have to be kind of holding constant here. So I need to be attaching this side of the load cell to the encoder. So you can see I'm just going from these screw holes here to these 3 screw holes. So that mechanically is a bit of an L bracket kind of thing, even though it might end up actually being part of a larger piece. And then that also would end up connecting to this, which I'm kind of keeping close by. So there's kind of a little triangle here that needs to be strong. And then there's almost another triangle here where this collection of stuff and this wider idler and the motor plus winch centered over here, like all 3 of these have to be connected to each other pretty strongly. So that's where I need some material, but then like over here that can actually be pretty sparse. And likewise over this way it could be pretty sparse. And so maybe that means that's a separate 3D printed piece. I don't know whether there's like kind of an endoskeleton that holds all this stuff together, and then there's just like a thinner shell that goes over the whole thing, or whether the whole thing is one piece with just varying thicknesses because this is 3D printing and that's fine. I'm curious what it's like if we just angle that board, but it's going to look so janky. I was thinking just like 45-degree angle, but then even like the RJ45 would be at an angle in the back, which is kind of weird. And if I angle it all the way that way, now it's much easier to access this circuit board, which is actually pretty worth it. What if we made the RJ45 come out like near the bottom? Because this could be, I don't know, that doesn't really save any room. Kinda. That's not as bad. I guess this could also pretty easily stack on top of something else, but I mean, I'd probably rather stack my thing on top of this and use this as the base plate. So I could also easily cut these headers if I needed to, but that's probably fine for now. What does that look like? That also doesn't really leave these super accessible. Maybe let's think about this and then model the other boards that are going in here, because I also have that motor driver and load cell sensor. I could see the board going in on like sliding rails like this. That might be kind of nice. You know, if I did it like this, I could just have a stack here where there's, you know, another board above this or below it that has motor driver. And I was figuring the DC jack would be panel mount because where that goes, like I probably want to optimize the DC jack for such that the cable doesn't put strain on the connector with its weight. Okay, let's leave this here for now. And what's the next piece I want? I guess we can model the next two in Fusion 360. New design, Winch Bot references. Let's do the HX711 breakout. This is the load cell sensor board. Actually, let's take a look at the data sheet for that too, since I'm curious. I haven't looked too closely. I mean, I looked really briefly before buying these on eBay, but I haven't really used them yet. So we're going to have one of these in each of the robots. This looks pretty integrated. I don't remember their update rate being especially fast. Oh, 10 hertz or 80 hertz, that's better than I was expecting, but of course we're going to have to filter it probably. Well, that's neat. So I have a board. Let's get that on the camera. So really simple, but I care about where the mounting holes are. It's really possible that maybe we end up wanting to put this on another circuit board instead of mounting this directly, but I think we'll take this one step at a time. So the overall thing, I'm going to round that up to, well, that is pretty much 34.2. be 4.2. Let's actually start a sketch, otherwise I'm going to forget these values. And this axis, $21.2. Just making boxes for the headers since these are 0.1 inches. Well, on a 0.1 inch grid. 0.4 inch. 0.1 inch. Yeah, this is one of those easy things I always struggle to do in Fusion. Like, I want to take this and put it center on this line. But, like, if I highlight both of these and hit midpoint, that would actually attach the midpoint of this line to the midpoint of this line, when actually I want the midpoint of this line to be on this line. And I just don't see a way to do that easily. Chip. I'm just actually going to put kind of a big blob on here to represent the thickness of all the circuitry, because the chip and the capacitor are all about the same. So something about 22 millimeters wide, 2 millimeters thick. Selection. Like, I think what I have to do here is make a point, which there isn't even a keyboard shortcut for. And then put the point. Well, that happens to already be there, so I need to move it off of where it... maybe I should have done this part in Rhino too. Oh, that didn't even automatically make a constraint. Oh, man. Another center line. Okay, that's all the sketchiness I think I need here. So all of this is going to go down to form the circuit board. Call that 1.7. Wasn't done with that. Then this will go up a little to represent the component thickness of about a little over 2 millimeters, 2.25. And then I'm also going to extrude these up a little bit to represent the space that would be taken up by wiring. Oh, do I not have holes here? Oh, right, the holes. I missed those on the sketch. The holes are over here. Holes are lined up with this connector. It's like 15.2. And these are 3 millimeter holes. All right. I think that's all the things I needed there. Okay, backside is flat. Yeah, backside is all ground plane, in fact, which is nice. Okay, so that is our breakout board. Let's go ahead and, well, let's make the circuit boards look a little bit distinctive at least. There's a circuit board shader already. That'll be fine. was hoping to keep red as a contrasting color for the mechanical parts, but now I have a red electronic part too. Alright, there's that little board. This one could stand to go close to the load cell. Oops. I wanted to keep most of that move. This seems roughly like where I want it to live, but this clearly needs some cleanup. Then I need the motor driver, which is, I think, the last of these circuit boards here. Other than whatever maybe we make. I don't know if there's going to be a custom circuit board for this project, but there might be. Let's try doing this one in Rhino. Thin PCB on this one. Okay, so this board is square. We have, well, there's a big heat sink. There's some connectors and capacitors that are all about the same height. And there are some mounting holes. Let's do the mounting holes next. Three millimeter again. And it looks like the centers are 3 millimeter from the edge. That's pretty easy. There we go. Made some holes. And how are we locating this heatsink? This model, it just has to be really rough. I mean, I need to mount it, but everything else is just about leaving enough space. 24. Yeah, 16 by 24. $25. Let's see, 26. Alright, that's my model of this so far. Connectors and capacitors and heatsink and circuit board. What is this called? HW95? I don't know if that's a real code or what. Call it L298 breakout. L298N. Another step file. Oh, it too goes back on top of the rack. That board is wider than I would like, but it doesn't really matter that much. It just might affect how I design this back plate. Let's also open this and set the colors a little bit. This also This is also a red circuit board. Oh, I have to download this coding. Okay. And then just embedded in that stuff. So now this one electrically kind of wants to go in between the motor and the power supply. Mechanically kind of just wants to go wherever I can get the heat out pretty easily. I guess mechanically it might be useful to know which direction the fins are going in this heatsink too. It's going vertically along the circuit board here. But then it's got screw connectors all along this side. Now I'm pondering using the rotation of the winch as a fan to cool off this heatsink. That doesn't seem reliable. I'm just thinking about how this assembles and which direction the board should go in, like with the wires attached. Since all the blue parts here, they're actually screw terminal connectors, and I just canceled that entire move, which is not what I wanted. Oh, right, this move. Move, there we go. Oh, I think I know where this goes. This is way out there. All right. I think maybe I can expose part of this heatsink to the exterior of the case, or at least give it some airflow, but then still have room for wiring around here without it getting in the way of anything. And then this also might go along with some kind of stacking circuit board design. Something like that. There's a lot of extra space, but also not enough space. I mean, maybe it's time to reconsider the motor placement, or the motor angle at least. I mean, it's easy to rotate that anywhere I want. Maybe I try rotating the motor so it's out here. I mean, I guess the problem with that is that I was trying to keep the motor, because this is heavy, and I'm trying to keep the center of gravity close to this edge. Let's check on the printer. Oh, let's put that together. That'll be a good interlude. Fresh off the printer. So we've got some supports and a little bit of stringing, but then it's ready to assemble. I think I just sent the tip of this knife flying, which is probably going to make for a wonderful day with my foot later. There's a really annoying piece of support that just lodges right in the edge of this, but most of it comes out really cleanly. Focus. This surface is important because this is what the screw sits up against, and there's a little bit of a mess from the supports attached here. All right. And holding that at just the right depth to focus is a little tricky. Maybe it mostly just needs these little boogers cleaned off from the inside where we're about to put the pulley. It's looking nicer in there. So this will be a pretty tight fit, and this has to flex a little bit for the idler to fit inside. So these curves down there have to be, those have to be strong enough to kind of flex outward without just snapping. So having it spread out that stress a little bit helps quite a bit with this process not breaking anything. A little bit of support material in these holes for the load cell. Alright. We could be a bit more of a stickler about the cleanup here, but this is plenty. You know, if little strings of plastic end up rubbing on the nylon cord, I'm sure they'll just abrade away with friction pretty easily. So, there's our bracket. Fits around a load cell, screws to attach the load cell. Then this pushes up against the bearing and supports it, holds a nut. This is kind of a collar around the screw head to hold it from the other side. Sorry about the noise. I just trimmed my fingernails and I only have a whiteboard, but we could try that. Alright, so then the next idler, I've got one of these already prepared with a bearing. So the side with the exposed bearing goes toward the nut. The side that looks kind of like the screw head goes toward the other side that looks kind of like the screw head. And then we should just be able to press and hope that things fit without breaking. There's a bit of a wiggle to it, I think. There we go. So, and that's not spinning smoothly yet, but let's put the hardware in, because it needs to be centered. So this takes an M6 by 16 socket screw on this side. And so that'll start to bite in, and that screw head will start to sink in below this level quite a bit. And then on the other side, it'll start to really want to grab a nut. Let's give it a nut. And some focus. All right. Excuse me. It's a little misaligned. Let's help it. All right, so it's lined up right. Now we just have to tighten it. I just don't want to move because then it might throw everything out of focus. Cool, so it's tightened pretty well. There are a couple of places where it's catching, actually I think because of some goobers on the pulley. There's a spot where it's catching a little bit, and I can't quite tell where it is. It's right there. I mean, rotationally, it spins freely. Going that way, it catches right about there. I think it can help it out. Dale was asking about this Windows. This is a native Windows. This is my machine that actually has a decent GPU in it that I'm doing CAD on. Yeah, I don't quite see where it's scraping. I kind of do. I mean, it seems like the entire bottom side of the channel that the pulley is sitting in, it just has some gunk in it somewhere. I guess I lied about the cleanup being about done. There might be a little bit of 3D printer cleanup to do on that part. So that comes out. And then I think it is actually possible to get this out without breaking anything. I mean, I know I've done it by looping a piece of cord in there and pulling it out, but I think it just requires a little bit of a bend. So, yeah, I think there was a string down here. This maybe could have a little more clearance than it does. Yeah, there are definitely multiple computers and lots of VMware happening here, as Microhex says. Yeah, the CAD was running on a Windows 10 machine, but the streaming is running on a separate Windows machine. Neither of those are virtual, mostly because they both need direct access to the GPU to do the video encoding and/or CAD that they're doing. Alright, that seems a little cleaner. Let's try putting that back together. Focus. Really rattly when it's not tightened. Oops. Oh, that's better. Yeah, so that's properly how that part goes together. Nice smoothly spinning idler with plenty of strength to it for this application. And then we take a load cell, so these are just pieces of aluminum that have a big old machined hole so that they have two really weak points where resistors are attached that experience a little bit of stress as the metal stretches underneath. So this is not symmetric. This end is where the cord comes in, and this end is where the cord does not come in. So that goes on there. And then get a couple of screws to go in there. These are M5. No, these are M4 by 16. I need more of these. I have had some experience at running CAD tools inside a VM, but it's probably not something you'd want. You know, it's more something you do to show that it's possible. Oh, Servo AF is not doing much good today. So yeah, I was thinking about load testing this part until it breaks, but I think it's probably going to be plenty strong enough, so I'm not going to worry about it too much. Just from handling it so far, it seems like it's probably a lot stronger than the load cell. These can tighten up pretty snug. All right. And then the way this is going to work, cord will come in this way from the measurement capstan, and then it loops out vertically, and then this is what actually goes off to the ceiling. A little hard to hold everything, but roughly like that. So I'd certainly like to test the next part, but I don't know if that's going to have a standalone bracket or if it's actually going to be part of a larger assembly. Mike is asking, are you using paracord? That was my plan. It seemed like something that was going to be strong, pretty light, not likely to hurt anyone if because I figured if I was using metal cord and, I don't know, it seemed likely to take a lot of space for storage, and if Tuco got a hold of it, then he would just end up biting it or something, and this is a little safer. Yeah, Mike mentioned it can be stretchy. I'm aware of that. I'm expecting this to stretch. I'm not really too concerned about that. So that's another assembly. I think that's all there is for that. We've got two now. Can build a few more of these, but mostly get on to the next part of the CAD. So I think this is roughly what we're dealing with. Assuming we're using kind of off-the-shelf circuit boards instead of making a bunch of custom stuff, this would be the dev kit down below, motor driver, this is the load cell amplifier. The optical sensor, I think, is already going to give us outputs that should be pretty usable on the dev kit. They might require some resistors or something for level shifting, but that would be easy enough to just plug on top of the dev board with a little tiny circuit board. So I think that's about all I had for this stream. I know this hasn't been a long stream so far, but I just wanted to do a little CAD and show some parts that I had so far, but I think this might be a good time to get back to doing kind of off-stream stuff like video editing and figuring out what to do next here, and that kind of stuff. But as always, let me know if you have any suggestions. Either we have chat available even in between streams via Gitter. Oh, it looks like I inadvertently moved something. Or is that just the perspective? Oh, I guess that was just the perspective. Oh, no. That spool is definitely not lined up. All the measurement stuff is lined up, but the spool and motor isn't. So maybe we have a different amount of space than I thought. What is this joint? I don't think there's anything keeping this aligned with the rest of the objects here. Can I solve that with joints? What can't you solve with joints? Let's try this point in the middle. And then, can we force that point to be on this plane? With a planar joint, maybe? I guess I could base it off of a point, since it doesn't seem to like things that aren't points. Oh geez. None of that is what I wanted. Oh, interesting. Highlighting this curve seems to give me a point that also has the right orientation in the middle. So let's try that. You can see how not lined up those are, though. Why is that off by a millimeter? So in orthogonal, we should see all the pulleys lined up. All of these seem lined up. But when I was trying to add a joint, it was really hard to pick something that would actually be the right kind of constraint. I guess times like this, I just find myself confused about the object model of this whole program, because I'm in the situation where what it tells me is that it wants a component, but it clearly doesn't want a component. It clearly wants something more like a point, but it's a point that it also cares about what component is attached to it. It's also a point where it cares about the orientation of the point, since that's how it orient the component somehow, but like, and that orientation kind of comes as an implicit piece of data along with whatever that point is being generated by. But then, because like if I highlight something, you can see in this UI, which is based on almost invisible objects that you have to pick out, there's a tiny circle. I can't point to it with the mouse because then it would move. And I can't point to it with my finger because then you wouldn't see it. I guess I could point to it on my screen with the camera turned on. Yeah, so see that tiny circle? It's like below my mouse. That's the point that I have selected that goes along with the line, or the profile, I guess, up here that I've got my mouse actually on. But I don't know, like I want to package my components in such a way as they have like an easy thing that I can feed into a joint. Like whatever joints want, I want my component to have one of those such that it's easy to assemble it. But I just don't see how I mark that up because it's just this weird object that seems to exist outside of their normal object model. So, and so here, like I made a point, which you can barely see because everything is sublegible in this program. Did I lose this point somehow? I think it's that. Oh geez, maybe I don't even have a point here. Well, I mean, I've got other things I could put on that plane, like this point. But see, this point has a different planarity to it. This is not a point. This is not a component. This thing that you're asking me for probably has some name if I were to go find the source code for this that would maybe explain what's going on a little bit better. I can select something else along this line, and it has that orientation, but then the orientation changes when I jump onto this point. This is terrible. What about the bearing surface in here? Can I point at that? And why can't I change the visibility of stuff inside a reference document? That's just weird. It feels like that should be, like the visibility should be something that the local document can override. Can I get what I want here? Oh, maybe that's what I do. Okay, it looks like what I'm actually doing is selecting one of many different kinds of objects that can be transmogrified somehow into points, and it looks like that process results in multiple points. I think this is the one where I can hold down Control and select one of these three. So maybe this is what I need, this point, finally, and then to attach it to a corresponding thing over here. But see, this is why I would like to be able to temporarily hide stuff. That's the bearing race. Which I guess I could use that because that's centered. I think that's kind of what I want. No. I just really don't like this program. Oh, wait, did my bearing come loose? Do I need to go add a bunch of joints inside this part? I just undid something that I guess I didn't want to undo. Yeah, my bearing is now not seated where it's supposed to be. I think I've got to go in there and add some joints. Uh... I have this joint. What is this joint for? I think this attaches the spool and the motor. Oh, I've got a bunch of joints. These 3 are for the screws. This one is what? I think that's attaching the bearing and the motor. I'm not totally sure though. What is this doing? This is attaching the set screw. And then I think this one's going to be attaching the nut to the set screw or something like that. Is there a way I can tell what is selected? Because 1 is not really a helpful identifier. I can break everything. That's always what I want to do. Like, this is just the least helpful UI. It's a selector box that doesn't really actually tell me what I'm selecting because these aren't actually components. They're just like fragments of components. And then once I've selected something, it tells me what, but now how do I edit this? I guess if I hit this, it's done something weird. What is this actually trying to tell me? And then over here, I guess that's what I've selected, that blue thing. And I've attached, oh, okay, there it is, the nut. Okay, I know how to read you now, fine. Why doesn't it do that on hover? That's weird. Okay, can I name this now? Bolt to nut. Is this the nut to the motor shaft? The bolt to the whatever this is? Whatever, I'll just call that set screw. Oh, these are the ones I would like to group, because these are all just bolts for the motor. I don't understand the purpose of groups in this program, because they don't actually clean up the tree at all, which is what I want a group for. But whatever. So I think the gist of this is that I have the motor and the bearing attached to each other. I don't actually know what the set screw is attached to. I think it's attached to the motor shaft, but I'm not really sure. And then I need to attach both of these to the bearing. Can I do this in section view more easily? joint. Selections. Oh, right. This is, so joints join components. But now I've got a problem where I'm joining, like I need to join some stuff that isn't in a component yet. So do I have to put that in a component? I was always, like, part of the reason I'm using so many separate files is that the process of turning stuff into a component just doesn't quite seem to organize them in a way that seems organized to me. Like, it just still feels like a huge mess. Well, let's see if I can turn both of these into a single component. I guess that turned it into two components. Rigid group. Okay, so a rigid group is a type of joint, and it just holds things where they are, which is what I want, because these, like literally these two halves are glued together in this particular configuration. Let's name that spool halves glued. I still need to join this to the bearing. I should be aligning this edge. This is actually where the bearing is sitting. I think that's the thing that we wanted. You can also get a closer look at the inside of this thing. This is the joint that's glued. This little flat and this little flat are actually holding the bearing, and that actually keeps this aligned during the glue drying. That's where the bearing sits. And then the margins around this hole are distributed such that it sits totally flat at the bottom, but then there's a 1/4 millimeter of space once you get to the top. Captive nut. This, is it just me, or is that further out than it usually is? Maybe it's just me. I mean, the motor can go a little bit further in, but it doesn't really need to. Well, let's not have the analysis on all the time. Let's update that and then see if we can join these all together the way we want. So this joint should be keeping, so I haven't picked like an actual position for the idler here yet, but this joint is keeping it planar, I think. Oh yeah, animate joint. A little earthquake that tells you what happens. Let's see if we can just line up all of this stuff then. Some other planar joint maybe? I was just trying to use this one as a reference for the plane since it's got a nice bearing in there that I can't quite see. Is that the bearing? Planar. Really? Why did we leave all this stuff behind? I wanted that to be part of the component. Whoa. Okay, why was that blue? That's the selection color. It shouldn't be blue. Okay, well, I think this would have been easier if I'd created the component somehow first and then created everything in it, but now I've got this situation where Fusion makes it really easy to move bodies into a new component, but then leave all of their dependencies and sketches and things behind. Which is really not what I wanted. But I'm gonna try to make do by at least hiding all the stuff that's not gonna be right. Does this work? Oh no. Yeah, I guess that was connected to potentially nothing. So the set screw here, I don't know what it was actually attached to, but I don't think it still exists. So that is the tip of the nut. This is supposed to be a sketch feature. That's, I think, what we wanted. And everything else builds out. Oh, I think we're missing a fillet. There's supposed to be a thin fillet around this edge. Maybe that'll stay together now. There's gotta be something about the dependencies here, like maybe, I mean, this would, I'm sure, be easier if I was referencing a feature on that body from after I converted it to a component. This is the set screw positioning sketch. Can I just make this sketch happen way later? Can this happen like now? Well, maybe, oh man. Maybe let's try defining this without referencing that sketch, but still use that to make sure we get it right. What am I doing? I don't want to be editing that sketch. I want to be editing that joint. Why can't I select this thing now? The motor. Now I'm just trying to attach the set screw to a point on the motor. And why isn't the motor real? I don't know why these objects aren't real. Like, it says to select a component. I'm trying to select what's actually a point on an edge on a component. The component's visible. The components' bodies are visible. But it's just grayed out all of a sudden. Does it think they're on the same component? Like, we have these 3 screws. We have this screw. And this motor is another component. Those shouldn't have any reason not to be independent. And delete this joint and remake it, maybe? I don't even know where the screw went when I deleted the joint. And so that is exactly where I want it. Maybe I make these a rigid group. Is that a thing I could do? I mean, now they just aren't going to move relative to that position I set right here on the sketch, I would expect. I can roll it forward, I build all that stuff around the set screw. Now we update this. Did that resolve it? So that screw seems to be in the right place. This is kind of wacky, but whoa, what is this button? Edit joint limits. Why is this not a planar? Which joint is that, though? I don't see that in the list. This is weird, too. Can those constraints coexist with me moving components? And does that enforce the planar? No? How are you coping with that no longer being planar? Are you just not? Did I not actually have a working constraint there? What about on this? Why did it let me do that? I had a planar constraint. I still have a planar constraint. Where did that even go? Is it supposed to be this? That tiny thing that I can never zoom in on, is that the planar constraint? Looks like it. Oh, drive joint. That seems useful. Oh, I moved the load cell. I really didn't want to do that. Well, I don't know which of the joints this is, but let's try driving it. I guess it's this one. Okay, I think I must be missing the joint here, or it's just not showing up in the list for some reason. Can I rotate this too, or does that require another joint? Roughly there. Spool planar joint, maybe? Oh, this has an angle. Can I not set the angle? How do you even set these? Oh, this little thing. Yay, that's what I wanted. Great, so that'll be somewhere like that. That's exactly what I want. Great, so this will be spool position joint. What is this? Is that just holding on the nut? I think so. Man, it really is spot the pixel trying to figure out what you're actually selecting. Ah, what are you? This is joining the screw and the bearing. Well, I don't know where that planar joint went. I sure thought this was another joint. Oh, that's just the bearing attached to the wider idler itself? It'd be nice to know what is still under constrained in this mode. Okay, so I think the best Solution for planarity so far was to do a planar constraint, but select the inner part of the bearing, which will give me a point with the right orientation, as ridiculous as that is. So going from there to a reference over here again. And motion is going to be planar again. Huh. Okay. So this will be the wider idler position, which I can move by driving the joint. Vroom, vroom. Seems sensible to use this as an anchor position for stuff that it doesn't necessarily need to be relative to the spool. Relative to the output shaft is kind of nice. So we can adjust that later. The wider idler position. I think we have joints in all the right places now. I think this is planar. I think we can move the circuit board a little closer. Still about the same position we were in now, but I think the model is slightly cleaner. So yeah, we've got a bunch of space over here. This stuff is still maybe bigger than we'd like. Oh, I've got an idea. Let's try putting that back that way. That might be all right. I think that might be all right. This wire can come out pretty much anywhere. That's not really a limitation. Let's make the wire come out the other side in that subassembly, maybe. What is this doing? How is this attached and how am I going to break it? I think this joint is attaching some kind of weird part of this. Oh, what is that? Why is that new? That should really be in the child assembly. What is this? I don't even know what that's doing. Just trying to move it with the move tool, which probably isn't going to work, but I'm going to see what breaks. That was interesting. So I select. I guess I'm just selecting that one component here. Rotate around this axis. That just seems to not do anything. Huh. Not quite what I was expecting. Oh. Is this already giving me the controls I want now? That's kind of nice. Oh, yay, I did have that joined. What happened there? How is this attached? Load cell to capstan. This is the one that feels like it should be in the other module. I think this is just attaching the capstan to the sensor. Is this the weird one? I think that's attaching this pulley right there. Yeah, that's super weird. Let's attach it. Can we attach it there instead? I don't know why this isn't updating. Was that not real enough? That come from? I don't know why those aren't connected. Idler bolt. Idler nut. This one is a problem. Oh, is that what I wanted? I think so. Let me adjust that after I go back and rotate this other one, but let's name this first. Capstan to idler joint will be that one. Okay, load cell to capstan. I can't drive this joint now. Let's make this a revolute joint. Whoa. I didn't want you to revolve around that. Okay, fine. You're not revolute anymore. Now, this one. Oh, geez, that whole coordinate system's rotated. Why? Why is it rotated by 45 degrees? Maybe I just want to remake that joint. I don't think that was quite right. that's the one I set aside. Oh, will that circle do it? Why isn't that circle working? Well, I guess I could use a different reference point. I could use this reference point again, even though it wouldn't really be my preference. No. I didn't mean to cancel that much stuff. It's very aggressive with the canceling here. What? Okay, so these are joined to be pretty much at the same position. I'm just moving this one over. So again, the cord goes under here, over there. So this does actually need to be able to put some pressure on. I mean, it will pretty much no matter where we put this, unless it's much lower. In fact, that might even be enough pressure. So under, then along here, then back down. Yeah, we don't want to put too much pressure on that sensor. Let's update these. Microhex says, almost don't need the Tuco flyer anymore. You know where I'll be most of the time. Yeah, he does really like that rack. Wonder if he appreciates those new DisplayPort repeaters. What is going on here? Are those not connected to each other? I guess they probably weren't connected to the new, like this bracket we have in here. This needs to be wrapped in a component. Even though this component doesn't have any of the useful prerequisites. Oh, what about this joint? I guess that's attaching the idler to the load cell. Oh, and these are motor screws. I guess I want to make a joint. Why is the OK button grayed out? Why? You could tell me. You give me so many useless warnings. You could tell me why I can't do the thing that I explicitly said I wanted to do. I should probably stop doing this. This is really frustrating me. No. I think that's enough joints. Let's see what happens. What is this stuff doing? Oh, geez, what? Okay, I guess it was out of date and didn't update. And now I've got a sketch way up there. I guess I should turn that off. Okay, so we have some positions we can set with joints now, which is kind of fun. And maybe we can finally put this... What? Why is that not... Can I aim that? I wanted this to be pointed out the other direction. That was the whole reason I edited that assembly. Did I just forget to save it or something? That's definitely saved. Yeah, no, I got it. Stop. Measurement assembly. This doesn't look like the latest version. That's right, I didn't make this thing a revolute joint. I just edited it so the wire's coming out the other side. So this seems like it should really just be pretty straightforward to update into the other document. No? Why? Do I need to re-import this piece? It says it's up to date, but it really doesn't look like it. Choose version. Yeah, so if I just add another one of these, the wire's coming out the right side. Wait, but what else is wrong with this? I feel like I've just had a teleporter accident. I guess part of the problem I'm having is using joints for situations where the connections are meant to be temporary. Like, I want to have some things roughly in a particular place while I figure out where everything else is going, and then I go back and try to fix it, and I realize that I've just made a permanent mess. Anyway, I'm probably going to wrap up the stream and take a break from this and come back and think about how to fix it up. So I don't know. So like, where are we? I'm really frustrated at this tool, which is part of where we are. But aside from that, I think we're in pretty good shape. Oh, geez, what a mess. So this is kind of the way I want this to be. The motor doesn't have to stick out this far. In fact, maybe I want the motor to tilt downward so that it has more room not to stick out. Is that this one? So, I mean, at some point that's going to start making it larger than it needs to be on the bottom side, but... There's plenty of room in here. Thinking about how to make it smaller. So I think this is roughly an okay position, but... maybe tilting the motor up and having the board on the bottom was a good idea after all. I'm back to this again. This sticks out the bottom quite a bit. Whereas I kind of like that. It's kind of a nice little spot for the encoder right there. So I want to avoid hanging the motor out here because that'll be, like, imagine the wall is over here. You know, I want to have a wall mount bracket for this. and so I want the weight of the motor not to be that far out from the wall if possible. Could it be a stand? It's kind of funny. That wouldn't be a terrible design if it was floor mounted all the time, but I think a lot of the time I want this to be wall mounted. Oh yeah, Mike is asking in chat if this software can model the center of gravity. I think it can do basic measurements like areas and stuff. I don't know if it knows about density. Center of mass, how does it do that? Right there. That's assuming it's uniform density. Like I just filled a motor-shaped silicone mold full of resin, and that's where the center of mass would be. Oh, that shows up as a persistent analysis thing right there. Yeah, the motor is big. I'm also just thinking about how to make this enclosure not so gigantic. I mean, if I'm trying to make the enclosure not gigantic, my priority should really be to have this motor overlap with the components up here. So that's about the best position I can get for enclosure volume, or envelope size and center of mass. Which pretty much leaves the circuit board on the bottom. Oh, this could totally be upside down too, if that makes it easier to access the circuit board. I could probably cut off the end to make it smaller, but that also seems a little overkill. This could have come in a little bit, and then I could have kind of a cutout here that allows the connector to have some room to hang out, and then some room to route the wire out along that. The forums suggest step. You mean like as an export format? Not sure what that's in reference to. I found step more useful personally for importing in like Rhino, but I figured I would export both step and igest because I don't know like if other people are using tools that import igest a little better. There's also all of this area. You know, if I used a little RJ45 extension, it wouldn't, or if I just don't care as much about whether the cable enters at a jaunty angle, then maybe I could put the cable up here. Let's try that while we're just experimenting. Spitballing, as I guess they might say. I mean, that is still going, like, the problem here is the thickness of the board in that dimension. So let's try flattening it this way. That might not be awful. You have an RJ45 way up here. A little overlap with that. This is interesting. Oh yeah, if you're talking about like exporting to a third-party tool, that's probably step the file format. Yeah, that's how I was just getting stuff back and forth between Fusion 360 and Rhino just now. Ah, I didn't want to escape. I wanted to stop doing the thing. I didn't want to cancel doing the thing. So, I don't know, we can think about this, we can maybe refine it, but maybe something like this. With the exception of stuff like that going on. And I can imagine with a design like this, either using a pigtail lead if we really wanted to position the RJ45 elsewhere, or just have the RJ45 go in the top there, and, you know, the RJ45 will go in there, the paracord will come out there, we can put power wherever we want. You can see I'm just trying to kind of pack this envelope a little bit. I think these circuit boards go elsewhere too, for sure. Like this motor driver. Let's reverse this. I could even go back here. That's kind of in the way though. I think I want this to be kind of near a back panel if this is going to be where the Ethernet comes out. I want this to be somewhere where it can have an external vent, at least for this heatsink. This can also be exposed for debugging over here. That's nice. Thinking about whether the circuit board needs to be upside down relative to where it is right now. Since this is likely to be kind of an inaccessible side of it all, I think this is going to be the front side for most of the assembly and disassembly. So I think maybe turning this around, this side being kind of inaccessible, but then this side kind of building stuff on top of that, maybe. Let's see if that works better. I probably shouldn't still be live. I'm still really frustrated with this program, but I haven't quite given up yet. Ooh, is that a better fit? I could, of course, cut off some of these connectors if I wanted that to be smaller. Oh, look at that. There's enough room for that RJ45. Just kind of sneak by there. So then imagine there's like a flat base on the right here that you then just kind of stack components into and then bolt them in. I don't know what's going to happen with this though, because like that's really, this is what needs to have a sturdy attachment to the encoder and everything else over here. So like there could be kind of a clamshell that just holds those parts, like the electronics on the side, but then the actual load-bearing piece needs to attach up here. I was also thinking about heat sinks. I like these pulleys. It's going to be a nice little flow with so the cord will start out down here. It'll unwind onto this idler, which will center it, then go down under this one, or sorry, no, it'll stay above. Then it'll go down under the capstan, and then under here, and then above. And this one, the wider idler, we can still move around. It's not really in a final position yet. That's just kind of approximately where I think it should go. Oh yeah, and this, we probably want it to have airflow, but not necessarily be exposed where people are going to touch it if it is hot. And where do the motor wires come out? If we're looking at it like this, the motor wires actually come out pretty much right where this RJ45 is. It's maybe a little more on this side, but that is maybe a problem. Maybe we'll change our angle very slightly here. Try that. A little more room between the motor and the circuit board. I could really start to crank those together, couldn't I? I don't think I want to, though. Oh, maybe that's a good spot. I mean, this is probably going to be a good place to put the power entry, honestly. So maybe this wants to be horizontal again. So there isn't really room up here, but the power jack could go up here, and then this could go down here, and wouldn't really take up extra space. Let's put it there for now. So that'll be hard to access the connectors with it in. I assume this means the board will need to kind of slide into place in this particular arrangement. So the outputs come out on the side, and then input power and enables come in on this edge. So this will have some wiring coming out. That's fine. DC power jack maybe around here. I don't know. That's our robot so far. Starting to come together. I'm trying to make sure that it just won't have any... Oh, that's like kind of a sticky outy bit already. I was going to say I don't want sticky outy bits because then I have to make the case larger to accommodate them. Hey, buddy. That looks a little better. I may have just moved that even more in the way of the wire. I was forgetting about the motor wire again. Yeah. This point is bothering me. But yeah, I think this is maybe a good time to take a step back and think about it. This is our Winch Bot so far. Big spool of cord, big 24-volt motor, microcontroller with Ethernet, motor driver, optical encoder, A to D converter for the strain gauge, load sensor with the strain gauge is on it. This is the idler that we're actually using to measure force. This is the capstan we're using to measure distance travel. This is the idler that keeps pressure on this capstan, and this is the idler that keeps the cord centered on the spool. So that's what we got so far. And this is also in GitHub. The GitHub is lagging what I've got in Fusion 360 a little bit, but my plan is to have the project kind of mostly live on GitHub. So we have the Tuco Flyer GitHub organization, and Flyer CAD and Winch Bot CAD is where we've been hanging out today. You can play along at home with STL files and step files and such, in case for some reason you need a cat following robot as well. Good job, Tuco. Happy hacking, folks, and happy Friday. I'll see you next time, and until then, see you on the interwebs and such.